Alright, we should be back. We should be back. It's not telling me I'm back though. I'm back. There we go. Right. Did it start a new stream? How annoying. Start a new session. I got 2 videos to upload separately. Right. Okay. So, what do I want to do now? So, turns out those safeguards were not safe at all, and I don't. Yeah, I just want to get the music back. You know what? Until we might crash again. Right. So what in here is just running on for too long. So I guess we should re-look at this Q code again. Like, so what we could do is we can so we can make let's find all the loops in the code, right? And just eliminate, let's just do process of elimination of this shader of what is. So these ones are capped, right? They're gonna be fine. At the end of the shader. Not any of those. These are all if statements. This is one big if statement. Well, okay, it's for loop. This one's alright as well, I'm pretty sure. We just give it like, yeah, it's hard coded. It's just one that's passed up. So the thing that's the problem is basically this code here, right? So, if I change that number to 1, so it only tries once, we'll be able to see if it takes anything from the queue. And then we can debug the first one going through the code. And that should be good enough, I reckon. So we change that to 1 for now. And if we get this to work, we put the music back on and we can test. So, oh, if I just sync that. Alright, I think that should be alright. And let's reduce this to like 16 or whatever, I don't know. Alright. Okay, it's crashed again. Oh, we're still here. I was getting ready to bail there. No? Okay. So... Alright, I think we're still okay. Although... Really not sure why it's messing up. So... I don't know if we take from the queue. So we could say regardless, let's just return, right? Let's make that max iterations 1 as well. Shoot. I think that is buggering up. No? Branches to the loop continue target, but not contained within the associate construct. Yeah, that return's messing up for some reason. Alright, that's not good. Yeah, I want to kind of like get it to do an early return. I don't know if that was asking for too much. Frame's asking for too much. I can't put a return inside a... Alright, I'll fix it up. Alright. There we go. So let's try that out. See if we... Alright, we should be back again. So what we found out then is it's not those loops. It must be different loops that are causing the problem. Yep. Hey, Jam on Toast. Welcome, buddy. How you doing? How's it going? Excuse me. So it's somewhere in this code. Is there another loop? Yeah, I got this one. There's this one right here. So what we could do is also we can max iterations this guy as well, right? So what you'll do is you just go, load. So I guess that'll become a do while, right? I barely use these guys, and every time I do, I'm like, you know what? You don't need to be a do while, and then I just like. There we go. So we do a do while one of them, and what I need to do in here is say, well, wait. No, I kind of want to like one of these max iterations thing again. Yeah, I don't need to do while. So what I want is one of these, and we'll essentially do like an if that's not, then break and spin. Yeah. Alright. I'm good. Heard you was on holiday. Hope you had a great time. Yeah, man. It was awesome. You know, the whole time there was really, really nice experience. Did lots of, sightseeing, eating tons of food. Relaxing, exercising, and not really spending much time on a computer. And lots of family. The travel there was quite an experience, though. Like on the way, it was just. I put it that way. We didn't sleep well for 24 hours, and yeah, but and the jet lag. You're kind of like there for 4 days, like trying to stay awake, but you're like a little zombie. But yeah, it's good that we had a whole month there, though. Put it that way. But yeah, glad to be back. Glad to be back. Right, so I think that's the only other loop in here which could be causing the problem, right? If not, we must be in like an out of bounds access somewhere, which could only be here. But I'm pretty sure the head index. Is equal to 0, right? We set it to 0. So Did we put sync code on that? That's a good question. This could be why. Oh no, we did put sync code on it. There it is. Alright. So it's saying read write, and then read write on the queue. So these will be waiting for each other. That code is tight. Alright, so I'm pretty sure that won't crash now. We can hopefully go from there. Fingers crossed. Wherever crashes, guys, I'll be right back, but it should be alright. Alright, we're going. Spinning for too long, one. Alright, so obviously we weren't spinning for too long. So the thing that I want to see is, do we get anything down here? And this one is going to be like, yay, a cluster. There's no yay, there's a cluster. So something is clearly wrong, but not to worry because it's probably quite easy to work out. So I think my queuing logic might be a bit, it doesn't account for the tail, maybe? I don't know. So anyway, we've got the tail at 1, we've got the head at 0, because we're going to insert the root node in 0 in the queue, right? So something is going on here. So let's just read over this and get it to work out. Nice, yeah, I bet the flight was a killer. Glad you had a good time. Awesome. Thank you. Yeah, I also took a 6-month-old who's now 7 months. So yeah, but he sleeps better than us. But yeah, one kind of good thing about the flight not being the best to sleep on is it kind of helps you adjust to the 10-hour time difference. Like basically by the time you sort of like but by the time you sort of get to the next day, you've already adjusted. Sorry, yeah, it's already like the evening time when you land, depending on your flight rate. So you can just like go to sleep their time, and then like you've kind of already adjusted by half of the jet lag. So you've like sorry, by half of the time difference. That's what I meant to say. So it's 10 hours. So you've already done like 5 of those hours, and then you've got to spend the rest of the 4 days to sort of like, 1, catch up on sleep, and 2, sort of get the rest of the way. Rest of the difference. But we had it a bit harder though, because the baby would just get up at like 3 sometimes, and you have to try and get back. Like he would just be like wide awake, and then also during the day, sort of around about like lunchtime, he would go to sleep in that evening type of sleep where he's like knocked out, and like you just can pick him up and he just stays asleep. But yeah. So now, what is the next printing code that we want to do? To figure out what the hell's... I want to read it first. So basically, right, the first thread, as this comment says, is going to get us a cluster from the queue. So 2 wave32s can go ham on this. And so yeah, the first thread goes in. So what it needs to do is get the head index and then say, oh, it's equal to the tail. I'm just gonna stay in here for a bit. And if we're all waiting, then there's nothing left in the queue or anything that's going to go onto the queue, so we're going to return. If not, we're going to continue back around and try this process again. Then if we find something, correct. Yes. So we must reach here, right? And what we try to do is a compare and exchange and go, you know what, let's take this head index, which is 0 initially, add 1 to it. And that's what I want it to be. But this is what it should be when I do the compare and exchange. And if it is that, it will return. Then it returns the original index. And to know if it is successful, oh, wait a minute. Yeah, this is to know if it is successful, you check against the original head index. Wait, did we ever increment this thing? Oh yeah, so what we're trying to do is increment it. Hey there, Diesels. Good evening. Can you please tell me what's your streaming setup is on Linux? Yeah, so I've got a AMD PC with an AMD GPU. I've got, when I bought it, I kind of got 2-year-old parts. Because let's be honest, PCs have not been getting that much better, and it was like way more affordable to do it that way. So I've got like a great 1080p setup. Basically, I can probably play games on like medium to high settings 1080p. I've got a Behringer sound thing here. So I've got some sort of what have I got? I've just got like a Logitech webcam. I've got a Behringer UMC24HD, one of these boys. This works on Linux, and it hooks up the microphone I've got and the headphones here, so I can hear myself talk and go crazy, but also well, yeah, but I hear myself talk and basically know what's coming through, and plug in like a microphone as well, and this way it should minimize the amount of like fuzzing and stuff whenever I plug it directly into the motherboard of the PC or something, right? It can really help out with that as well. And also yeah, so this works on Linux, which is great. What else do I have? That's kind of just about it. I got a keyboard and a mouse. That's not that interesting. I got a Corsair mechanical keyboard. I got a 1080p screen. But I've been trying to get a better screen, but that's about it for now. That is my setup. See, this sort of like compare and exchange. I remember thinking about it, and I thought that it was. The initial time I read it, I was like, how can you tell that if it's changed or not? Then I convinced myself you could. But now I'm trying to remember how I convinced myself that it was true. So let me just figure that out. So you got two threads that come in and try and do this, right? One's head index, or they've both got the same head index, where it should be 0, and they both go, you know what, that plus 1. So they both get here. Yeah, I can't convince myself about it because. Oh no 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 no. Right, this okay. This is how it is. Because one, yeah. Because one thread's going to come in here and say it's going to be 0, but make it 1, and the other thread's going to do it as well. But one of them is, oh wait a minute. Yeah, but yeah. One of them's gonna get 0 back because that's the original, but the next one, but the other one is gonna get a 1 back because of the way the atomic thing works, right? So that's why the one that actually did it can go past this if statement, right? That's cool. That's correct. So what I want to do is just print out this head index and just be like, you know, let's print out both the heads. No worries, no worries. Are you do you stream yourself? Or are you sort of looking into getting into streaming? Okay. So let's see, one, how many threads get here, and two, what are the values? Alright, 0, 0. So yeah, but we knew this actually, so this should both go through. This should go through. And also, oh yeah, there's only one of them gets there. Yeah, for that frame. No. Many of them get there for that frame. Isn't that interesting? Is this the wrong way around or something? Yeah, I don't know if I've, let's bust out the SPIV dis, and I'm gonna find compare and exchange. What am I looking for again? Yeah, I think I put it in the right. Yeah, I put it in the order of the SPIV gen. Yeah, 0, 1. And then we got the 2, 3s. So are those in the right orders? Oh, that's a bit too big. Semantic. Value compare. Ooh, I think that's the wrong way around. Yeah, comparator. Whereas I think I've got the comparator, as they call it, in the middle one. Lib HCC. What am I doing? Atomics. Looky here. So I've clearly got those the wrong way around. Can I take a look at like what GLSL's ones are? I do kind of like it that way, I think. Yeah, why did you compare in the middle? Yeah, they put the compare then the data there. Yeah, so what I want to... So I'm confused why they did it this way around if GLSL is that way around, but... Okay, so let's double check. Only the original equals comparator. Yeah, so basically I need to do that. So 0 is the return. 1's the... Yeah. So if I do that, that will change everything. So right now, I think a ton of threads are going through because what it's saying is, what's happening, yeah, I think tons of threads just going through willy-nilly. And because it's basically saying, hey, make it 0. But only if it's 1. When we want it the other way around, obviously. Yeah, so what I need to do is get a new version of the compiler in. So I'll just quickly shoot over to the HCC codebase. Oh my days, been here too much lately. Well, let's get a new version of this compiler out. I should do it for April Fools. Which programming language is this? C. Nothing but C. We've even got a custom compiler for shaders, so we can compile C to Spear V. So we can use it for obviously writing stuff on the GPU. So that's really awesome. Just going to get the latest binary and throw that in the repo. I should definitely have a script for this, but I don't, and I keep saying it every time. Okay. So if we take that for a spin this time, yeah, we should see different results. I think. Maybe. I don't know. Anyway, let's sync that and give it a run. There's no game because I'm not in the right directory. Alright, we've seen different results. 0, OG value 1. Isn't that good? So that means then those threads are not even going to get through. Meanwhile, there should be one of these buggers which does. And I cannot find it. But anyway, the way it goes. So let's hop in here. This shouldn't be one of these guys firing up. Oh yeah. So one of our boys comes in here and takes the valley. Except for it doesn't take the valley. Because for some reason, we look at Q. Like, so this shader here before should have just stored 0 in there. As 0, right? Yeah, that should be alright. What is going on? So let's look at the cluster index now. What is going on? Cluster index is U32 max. What? Why oh why? Must you play me like this? Is it because we didn't do an atomic store? But it's between shaders, so it should have literally just done the synchronization like as part of like, come on. Oh, U32. Yeah, it should have done the synchronization because it's between a barrier from the CPU side when we made the command buffer. But maybe it doesn't. Right, we're still getting the wrong value. Let's put that back because I don't think we need it. Not that it matters. Very negligible. It's only executed once, but still. Right, sorry. Right, so is this not behaving the way it should do in my compiler? Like, one way to check that is actually just do something like this, right? Just do the load again. Well, maybe it's not one way to check it, but let's just do that first. Right, that's still got the wrong value there as well. So, something is a bit weird. So, am I setting the right buffers? Volume constructor construct process queue buffer ID. That's in the reset. That's the one that gets filled in with the value 0. Oh my days, look at this code here. Memset. Memset's U32. Whoops. Right, let's correct that. Alright. So, yeah, that happened. But not to worry. So now we should, if we delete this, what we should experience is a, we should get to here and say, yay, a cluster. And then we can go on. Yeah, the only one that matters, exactly. C. Right, so here we go. Yay, a cluster. We made it. But there's a lot of guys saying yay, a cluster. Ah, yes, that's fine. There's 64 of them. Prove that. If we do this, there's 64 in a dispatch group or a thread group, we're going to call it. So there's two wave 32s going over it. Wave 32 runs in lockstep, and there's two of them running in lockstep independently. So they're kind of out of sync. So we put this around here saying, hey, the first one in one of those wave 32s, and let's go. No, that is not good. We shouldn't be experiencing that. Can I undo and double check with this? And also, let's make this code better. No, I should do that. Assignment in conditions. It's kind of alright sometimes, but I'd rather not to. Yeah, so what we're looking for now is we want to see this information. If this prints out once in a frame, boom. Yeah, I think we saw that, right? Once in a frame. Yeah, once in a frame, that's fine. So what the watermelon is going on here? You know, why oh why? Are we getting too many? Oh, no. Right, we have found another problem. This is a 4x4x4. That means we're going to get... when you do this, you're not getting the first thread. You're getting multiple threads. So what I should be using is the sphere index instead. Like this is going to be getting all the ones with x-axis of 0, which is actually like... there's 8 of them or more, I think. I forgot. Or is it 16? I don't know. It's definitely more than one though. So we definitely need to sort of like correct that problem in every other place that we do it, in this shader and in other shaders as well. So let's just go through and sort of do that now. Because that's definitely not the intent of everywhere where this is. As you can tell, I copied and pasted this error pretty much everywhere. But not to worry, it was that easy to fix. So I'm pretty sure. Yeah, we're good. Rightio. So what we're gonna do now is progress on with the shader and just see what it puts in that queue. We're just gonna analyze one iteration of this shader. Hey, Mr. Red, how's it going? Good to see you. It's been a while. How you been? I'm doing good. I'm doing good. Glad to be back. Getting back to doing some work and stuff. But yeah, I had a good holiday at the same time. How have you been? What have you been up to? Just curious, since you're translating C to shader, have you considered using this as a way to implement machine learning? No, because I'm not really that interested in machine learning. It's just not anything that excites me. So I just don't, someone could probably try and use it for machine learning, but yeah, I don't know. Most people do machine learning these days just use libraries that other people have made. But yeah, I know there obviously are some people who do the more low level stuff. But yeah. So we've got a cluster. Yes. So now what we're going to do is let it carry on, but we're also going to inspect it for some more information. So what I want to actually probably do is take that thing here. So we go over all these edits or whatever. Just quickly, let me just make sure this loop is not gonna destroy us. Oh, for crying out loud! Right, if that says 1 now, you know, I should change the crap. Not really a sphere index anymore. What is it? In that make persistent one. Oh no. That is okay. SV dispatch local index, that will work because you've only got 8 of them, which is not that great, isn't? But it's just the best way we could do it, I think. Right. Come on. Rightio, so hopefully this still runs, alright? Good to hear I'm doing good, a little busy with work, other than that everything's okay. Awesome. Good to hear. Thank you. Makes sense. Thank you for your response. No worries. Yeah, I don't know. I think some people want to try and use like machine learning for like actually in-game experiences, and yeah, that just sounds like a lot of work to get all the data. But I'm not an expert in the field, so I don't know. But maybe there's ways to generate the data and then train your network. Yeah, I've tried to do a neural network before. I gave it a go, but mission was not accomplished. I like trying things, but yeah, it's definitely one of those things where you spend a lot of time tweaking parameters of things and throwing through data and stuff. Right, so if this doesn't crash the stream, if it does, whoops. Actually, no, it won't. It won't, because we didn't change the if statement. Yeah, edit count is 1. Excellent. So now this is where. So I've only got one. We're putting one sphere in the middle of the volume, and we're just going to get it to fill spheres in there. So what I want to do is move that information to somewhere where we say, hey, yeah, I want to see this information now. If so I want to see the bits and bobs. So like when you put the sphere down, how many of the children are filled? It should be all of them. But I don't know. So you've just gone over all the edits and just seen if it's hit any of the children, basically. And this needs to be set in order to carry on to the next part, I think. Right. How's the baby? Teacher see yet? No. For soon. Not long. Yeah, he's just got his 2 front teeth, and he's eating 3 meals a day now. He's still not crawling yet. He still complains about being on his front, but he sits up pretty well now. Just yeah. Yeah, he's good. Like, he's a lot of fun. I'm always like flying around the room or tickling him or doing silly stuff with him. You know, as you do as a dad. You know, just yeah, do silly stuff. That's what's great about children. It gives you a chance to just be a child. Awesome, thank you. Yeah, so the stream dies. I'll be right back. This is just the way it goes on an AMD GPU. Right. So we're getting children bits at 0, but I did see it blink, and it's like, why is that different between frames? It just doesn't seem like something that's like. So what it's saying basically is, I'm going to stop here. So there's something really weird going on. I saw it blink, but I can't see it sharp anymore. Oh, there you go. We've got 3. Is that the one I want? Yeah, something's really wrong. So this is going to stay here and we're going to investigate more. So, do we reach... do we reach here? Yes. All right, so how many... what are we saying? So it's testing all spheres. Yeah, seeing if you land in there or something, isn't it? Yeah, I'm not doing the first sphere. Let's just do any of these boys. Right. Where's my yeses? Oh, so some of them had a... Right, it was blinking. Right, okay. So one thread's like... Sorry, one time when it does it, it's like, yeah, there's tons of success. But then in future iterations, for some reason, it still runs the same shader, but it doesn't get that. Which is like super weird. So the next thing to wonder is like, you know, can we print out the target LOD? Just at the start of the loop, does that work? Yes. The answer is yes, 6. So why is it 6? Yeah, so that's what I'm painting down as. I'm painting a LOD 6, which is the 250, the highest level of detail. I'm putting a sphere down that. So why oh why? Is the data just different every frame? So we're now going to print out a center position. I think we can splat 3 that. And now just put the dot x, y, z down, comma separated. Right, so let's take a look in here. Alright. I just see 128, so that means it's just in the middle. The center position is in the middle of the 256 cubed volume. So, looking good. It does that every frame, right? We're just seeing that repeated in the terminal. So, that is good. So, right. Let's just go here and just see like if it's intersected at all. Yeah, I guess I'll just do that so I can undo it. Just if we ever need to do that again. What are we doing, by the way? So so basically, like I did before I left, we was working on the volume constructor. So this takes a list of edit operations, like see, it allows you to paint down in a 256 cubed area with ellipsoids and cuboids. And when you paint down, it fills that area with spheres. And that's what we're doing, is we're trying to populate it with spheres so we can sort of compress the data down on disk into this list of edits, and then but also save the history of how the person made it, so you can undo in that when you boot the editor back up and that. So it's useful in multiple ways, which is what makes it a good solution. So we built the first version, but it was built with 2x2x2 clusters. And I did some benchmarking and was like, yeah, this ain't good. So we're doing 4x4 clusters, sorry, 4 cubed clusters. And this is the number that was that's kind of suggested, because it's kind of like, it just makes sense because it's the multiple of it's a multiple of a wave size on a GPU, and it's not less than a wave size, so you can do it's just better that way. There's some other reason as well. Effectively, you're reusing the same sorts of memory because you're dealing with one cluster per thread group and not multiple clusters per thread group. So I did the version of that, that's why it says V2 in the title. So we've just got it all compiling last stream. And this stream, we're trying to get it up and running again. We are reusing a lot of code, so it should be easy, but I don't know. I feel like I'm debugging some code right here, which we've already looked into, so I'm a bit confused. But maybe it isn't this code and it's just the code below. But yeah, it's basically now that I've written the first version, we're doing a second one, and this is going to be good enough. And then we'll be we'll have our first cluster working, which is first volume working, which has LOD, like levels of detail. We'll be able to put a slider down, test that all out, and then from there we can try and get multiple volumes and then instances of those, because right now we haven't got like a custom allocator for volumes in GPU memory. We're just saying, hey, write it to the first part of this buffer. So there's improvements to code like that, but what's great is from here on out, we shouldn't be doing some mega rewrite, which means there's no graphics on the screen. So we should be able to just have visuals from here on out, basically, which would be cool. Yeah, exactly. You need that. When you haven't done something before, you need to have at least one or two. Sorry, you need to have at least one version you can throw away. It depends on how complicated it is. You might need to rewrite it a few times. I think my Vulkan stuff I did like 3 times. Some stuff I've done as much as 7. Because it was that much of an understanding I had to grasp and learn. Yeah. Right. Has intersected. That is a blinky bugger. Sometimes it shows 1s, sometimes, and most of the times it shows 0s. Not good. So here's the 1s, here's the 0s. Why? This is what we need to find out. So one of these variables in here is being a bad. So that should be 64 grid cell half dims, because oh my days. $32, does that make sense? 256, you've got 4x4x4 in there, which then means it's 256 divided by 4, which is 64, then it's half of that, because it's half a grid cell. That's 32. That is correct. I was thinking of a different value there. So that's okay, and it's consistent. So is the rate, so we undo, we'll get this boy back in here. So we can now do these 3D coordinates and that very easily. So what about this rotated coordinate input? Is that just being weird? Right, a jumpy value. On the x-axis, it's like all over the place. Okay, but the y and z are fine. Why is that? Hope I don't jinx it. Nah, I'll be right. Be right, I've thought about it enough. I also know what game we're going to make as well, kind of, so I'm like, they're going to be fine. Highest, yeah, I think this vector's messed up because we know this input's fine. So let's look at that one. It's just a bunch of zeros. Coordinate highest LOD. Something feels a bit wrong. So what does that one mean, right? Coordinate highest LOD. Sorry, coordinate too high. Or at LOD. Coordinate construct LOD. What the crap is this? That's not right. Yeah, something's a bit fishy here. The construct LOD. That's not the construct LOD. Yeah, this is messed. Hey, Ospo, how's it going? Does GBH enough trigger callback on CPU? How does it work? Yeah, run to buffer. So we've got a bit of magic in HCC, which can take a string literal and turn it into an array of U32s. So there's like an intrinsic function call which basically takes a string literal. It takes this and turns it, and then takes a buffer in, and it takes an index to write to. And that's an intrinsic that's built into the compiler, and the compiler's like, hey, I'll write the necessary SPIR-V code in the SPIR-V backend that will take this and then put it into a buffer. So that's the bit of glue that goes on, and so what it does is it turns this into an array of U32 words, and yeah, then it will write into the buffer, and then basically we pick up next frame on the CPU and then just write it out using regular printf on the CPU. So it's pretty handy. It means you're not guessing and putting if statements down, turn things into colors, which is useful for certain problems. It's how to go. What game? What is it? It's going to be probably an RPG, sort of top-down, turn-based RPG. But I want it to be quite complex. Like, I want to try it to be like simulated, basically. So there's a beginning and there's an end, but the rest is completely unique for the player. But I may or may not make the first run a specific thing. I'm not sure yet. But I want there to be replayability, you know, and like different experiences that you can get from the game. So So I want there to be some level of simulation, basically, um, where things just work organically. But it's also got to actually. It seems like a system that can definitely break easy and be a bugger to debug. And it's definitely something I can't build fully by myself, put it that way. But I want to build the initial foundation and just see how we go. Initial foundation, de-risk a lot of the sort of things where it's like, oh, this could be a problem, and then sort of like progress from there. So I've got like a story all thought out and stuff like that. You know, base story and that. Yeah, it's gonna be cool, right? Because I really do like RPGs and played a ton as a child, but yeah, these days you don't really see evolution in the area. And what you kind of want, because you know what's really weird in an RPG is you can spend forever and not do the thing that the person that not do some thing which seems pretty immediate, and then you can just go up to that sort of place where the event triggers, and then all of a sudden, like it's as if you've just walked over there or something. Um, you know, and also yeah, just it's just a very linear path of basically what goes on. You do get branching stories in that, but yeah, and side quests and stuff. But it'll be interesting to see how sort of organic feeling you can make it. Because I imagine basically it's like you could make it to the point where there is no such thing as a side quest because you're you're creating a path through that world which is is the path that needed to that led you to get relationships with people who would then join your team, or you'll get items that you know, and it would just be like an organic thing that went on, versus like, hey, these are main quests and these are side quests because we've made them that way. um yeah. um yeah, so this coordinate, so what is this chord thing that we're looking at? So coord at construct LOD. That doesn't make any sense because you know the construct LOD. This is per edit. The edit has. Oh no no no. Oh wait no. This is the construct. Sorry. Yeah, the current LOD that we're constructing. Let me just double check. So it's saying what at highest LOD, to highest LOD. LOD. Yes, that'd be 0 or something. On the first one. That'll just go all the way up to. Um, we've been doing some AI stuff in the game. Yeah, so basically, right, essentially you need some complex AI, um, where it's basically simulated, where you need to know how like but I'm not sure how simulated I want to go, basically. Like, so they need to know this sort of like they'll have relationships with certain people at other entities. They sort of live in a place and they have a certain job that they do, and you know. But I need to. I've thought about systems on how I could design like how these things could happen. It's whether those things are sort of emergent through the systems that go on, or they're kind of quite high level, but it sort of feels as if they are simulated, right? So yeah, and obviously the more simulated you go, the more complicated it is, the longer it takes to make. But it's just trying to deliver that experience where things feel organic. Yeah, so why is that 0? They shouldn't all be 0, right? To put that out, it should be 0 to 3 inclusively, right? Allowed. Right. I just realized these are integers. Okay, so we're seeing this value change now. So it's something to do with this x coordinate for some reason. Oh no, it's meant to change like that. But it's not meant to change like this. Yes, yeah, it's a very weird big value as well. There's something very wrong about it. So why is this value? Just look at that construct. Oh, I'm using dispatch index, aren't I, instead of... Yeah, I'm using dispatch index, which is the... Well, it needs to be local. Yeah, so 0 to... yeah. Whereas that was just doing it over the whole dispatch, right? So then it's not really... Is it a construct LOD? It's not really... I don't know what I'm constructing. But ultimately, what am I trying to achieve? Where those variables going into? That one's kind of pointless. Our highest LOD. So we need coordinate highest level of detail. But you know your coordinates from the node. So from the node, it has a location. So yeah, so from the node it has a location. So you want it at called a cluster LOD. And that'll just be position. I want it back as E30 times 3. And I want to get it from node location. Then I am then adding onto it the dispatch local. So each thread gets a sphere within there, right? Then we need to convert that into the highest LOD. So we're going from the cluster LOD, which is yeah, so we're saying how many LODs of a difference is it from the cluster LOD to the highest LOD? Then we shift left the coordinate cluster LOD to you shift it left, so it ends up becoming coordinate highest LOD. So this means it goes from being from 0 to 4 on LOD 0, right, to 0 to 256 exclusively. So then that means when we're going over these edits and checking if we're within an ellipsoid or a cuboid, we're using the coordinates of this 256 cubed space instead of the space of what it is at that level of detail, right? We're using that space instead. So that was what was wrong. So we're just gonna look at that data now. So quarter highest LOD, this should be something. Yeah, we'll see and be able to tell. Why is this buggered up? Oh. I think that's right. It should be intervals of 64. Yeah, because yeah. 0, 64, yeah. And then 64 plus that is yeah, be 256. Perfect. So that's what we want. And we're getting children. Boom. Yeah, so we're always getting children, which is great. So I feel like that's enough progress there. So we know we're getting children every frame now. Are there any books you'd recommend off the top of your head? I don't read books, so I have no suggestions, I'm afraid. Yeah, I just I'm the type of person who Googles, talks to other people, and tries stuff out. That's my sort of learning methodology. I do read like the odd blog though, when I'm Googling, obviously. Excuse me. Okay, so right now this is already quicker than the previous one, I think. Oh no, this is not a good test. This is only the first cluster. Right, we've still got to do the rest of the clusters. So, radio. So what else can we do? So we're going to go into here, and we're going to paint out. Oh, what we're going to do? Oh, sorry, I completely misread that. Yeah, so we have children. We're going to go into here, and then bump allocate the 8 children nodes, and then we're going to go for the first 8 threads. If that child is set, we're then going to get the start index loaded in, look at the child, get the child index, then set up the child basically with all the correct information, and then move on. So what we should probably do is right then if you don't have any children, it's gonna say it's a leaf node and paint it in the thing here. Paint it in the occupation thing. Right. So I want to put that there regardless. Just want it to stop. But I also want to analyze the this data. I want to print out this boy. I want to print out that sort of like volume cluster One of them. Float 32s, please. Do you want floats? Maybe Z32s probably. Yeah. So I want a so let's pause. You, and you. What is all this? My compiler crashed. It doesn't like what I was doing with the oh no, okay, I'm missing the brace. The brace. The bracket. Whoopsie. That shouldn't be crashing there. I figured out a way to do circular imports in my language. If that worked as expected, I will be able to import file A in file B and import B in file A without getting circular dependency error. Yeah, that's definitely possible. Yeah, you just got to architect it right, isn't it? You want to basically, you effectively want to do 2 passes, isn't it? Or be able to pause a job. Yeah, you either want to, yeah. How are you thinking about doing it? Are you thinking about sort of like pausing the job halfway while you're trying to get the reference? Or, wait, no, wait, this is imports. Import. Yeah, you need to do 2 passes, isn't it, or something like that. And get all of your declarations, store them, and try and process them enough where you can create the declaration or in some minimal state so it can be referenced. Yeah. That should be possible quite easy. But yeah, just a lot of code and refactoring though. Right, if the stream crashes, I'll be right back. You know the drill. Alright, we're still running. Okay, so we're getting 4 children here. Position 000, 400, 084. I'm a bit confused by that. Where is my ellipsoid? Like, what's the data look like? Did I put the ellipsoid on one side of it or something? Hmm. Yeah, pass to collect the symbols, resolve them. Make it work out not to resolve A, but it's forward. Yeah. Awesome. Yeah, incredible. Yeah, you want stuff like that. Yes, that's in the middle of the volume. That is, yeah, saying it's you know that big. But why should 000 be in this list of like, I'm here, like what? That doesn't make any sense because that's one of the ones in the corner. So if anything, the ones that are going to get hit are the ones. So there's only 8 children, bear in mind. So all of the children. That's interesting as well. Why is the children bit set 33? That's the problem. If there's only 8 children, all you need is an F, right? All you need is the 16-bit sorry, yeah, the first 16 bits. Oh wait, no, sorry. Excuse me, that was, sorry. Yeah, what you need is, yeah, you need the first 8 bits, obviously, isn't it, right? The first byte. So, okay, maybe that is fine then. I don't know, we need to debug this. So we'll keep this in here. So the question is then, why is it only triggering? So what we need to do is say, oh, has it intersected? You know what? So what we need to do is say, yeah, I did a little bit of a, right. So sphere index, and you want to say like, you know, if it got this. Okay, so we're getting, so 0 to 4 get, okay, so I think the way it does it, you got 64 of them, right? So it's a 4 cubed space. Effectively what you've got is, it goes along the X, and then the Y, and then the Z. So it fills up a 2D slice that goes sort of maybe top left downwards or whatever. I don't know the origins of it. Then it goes back along the Z. So the first row, no. The first element on the next row, no. But then it does a couple of yeses, and then no. Then a no on the start of the next row, couple of yeses, then a no. And then it's like a bunch of no's for some reason, which you would expect these guys to get the hit. So the thing that I'm a little bit, so, you know, we really need to print out like, probably proper coordinates. Here instead. So yeah, yeah, in the middle there, right, at the next row. For some reason the whole row, oh no, sorry, 3's the bottom, isn't it? Yeah, that's fine, that's fine. Yeah, this is looking alright. So, um, And then it does the next slice. And it's doing more and more of that, basically. Yeah, I think that, yeah, that's looking alright to me, that data. So, I think the problem is, right, is the way I've... So the thing is you've got a 4 cubed cluster. 4 by 4 by 4 cluster, 64 spheres. But the children nodes is an octree. So what I've got is I've got a bit of maths which basically takes a sphere index and then it turns that into a child index, right? And it's obviously, or a child, yeah. So if you're one of those 8, because there's 2 behind it, oh sorry, not even 8. Yeah, 2 behind it, yeah. You're one of those 8 spheres. That turns into, they all turn into the same child index. Because there's a 2 by 2 by 2 within a child, basically, in a sense. Or in the same space as where the child node lives. So what I need to do is figure out if that maths is correct. So the way we're going to do that is there's cluster child index. So this is probably what is wrong. So basically, yeah, I think that's already wrong, isn't it? 0 and 1 need to be in the same one, right? Along the x. And the same with the next row, 0 and 1. Yeah, so this is wrong. Damn it. Hey there, Klingon. Klingon. I guess Klingon, innit? How's it going, Klingon? Welcome. Yeah, so this is the way that we squish it, and I've just done it wrong. It might be this and 1. Because what you need is you need these 2 to be in the same one, these 2 to be in the same one. Like these 4 to be in the same, and the 2 behind it. And then the 2 behind those lot and the 2 behind that one need to be in the same one, right? But in a different one. You know what I mean, right? So there's four 16 slices, which makes 64, right? Spheres. So the front 2 slices of here in this area need to be in the same one, and the back 2 slices in this area need to be in the same one, right? So there's that sort of maths going on. So are we trying to and? It's not and 1. So and so we're trying to keep those and. So it's and 2. And 2 divide 2. That'd be a shift, so it'd be alright. So what we're saying is along the x, what puts you in, what adds 1 to this sort of child index would be, like, so we and 2 here, right? This will be 0, but these ones over here will have the 2 bits set. So we'll just, so 2, it'll be 2, then we'll divide by 2, then it'll be 1. So I'll add 1 to thing. That might have been what was wrong. Let's double check here. So if we say 4, if you and 4, right, these guys ain't got the 4 bits set, but these ones do. I'm not sure about these ones though. No, but the next ones won't, right? Because that's 8, right? So 8 will just have, that's the 4-bit there, yeah? 8 won't, 9 won't, right? But it won't happen until you've got to the 12, right? Then that has the 4-bit set. Sorry, 12. But that's the 4-bit set, right? So it's not the 4-bit that I'm looking for, is it? That's the 8-bit. That's the Y. So if you're part of this side or that side, so I give you 8. So if the 8-bit is set, then you're saying divide that by 8, I guess. That would be a shift. Or it could be an equal operator. Then it's the same thing as well, then the 16-bit, isn't it? And wait, you're not doing the next slice. You want to get anything after 32 in it. Yeah, so and 32. So and 20 in hex. Then divide by 20 in hex. Right, I think that is the way. Let's double check that. Is this some kind of BFs over a node tree? What's a BF? Define BF, please. But yeah, we're doing a tree node system. Cluster tree. Alright, so what we're getting now. The first 2 and 0, the next 2 and 1, excellent. The next, oh, what is that? Yeah, then the next 2 on the next row are in 0 as well, that makes sense. And we don't land in 0 again until we're on the next slice, right? And then that same pattern appears, excellent. Yeah, this looks correct. Let's just double check the Y's, what makes sense. These are in 1s. Wait, why are these in 1s? No, this looks wrong. So this is the last of the next row. Those need to be 1s. For the start of the row after that, those need to be in a different group. So the y-axis one isn't working. Oh, wait, why are we saying divide by 8? Yeah, so that would have just added 1 to that. What do we need to do? We need to do a divide by... So what value do I want you to become after this? We need to become a... There's... So the x is an offset of 1. This would be an offset of 2. Because there's 2... Yeah, and then this would be an offset of 4. We'll let the compiler optimize that out. Alright, let's try that out. Yeah, so we got 7 now at the end. That's alright. So, yeah, 1 1 0 0 1 1. Yep. Then 2 2 3 3 2 2 3 3. Then next slice 0 0 1 1. Yeah, I think this feels a lot better. And now you're getting, is this 8 of them? Yeah, you're getting all 8 in there. Right, that looks better. Okay, that numbering looks correct to me now. Breadth first search. We're not doing any searching, we're building a tree. So we basically got 256 cubed volume. We're starting off at the L0 node, where we're building a level of detail cluster tree where it's all filled with spheres. But we've got a shader which basically takes a bunch of edits, like ellipsoid, painting down, and cuboids that are painted down. It fills those with spheres, basically. So we're basically at a thread per sphere and a dispatch group or a thread group per cluster. And a cluster is a 4 cubed set of spheres. So we have this sort of way of building spheres when you build up the game. Okay, so that feels correct to me. So we're going to have like a sphere renderer, or probably an ellipsoid renderer because we're able to transform the spheres into different spaces. Apply transforms, bring it into a different space. So, I'm thinking it's time. Let's unleash the beast. I'm feeling confident. Wait. What I want to check after this is 1, what is the tail? And 2, yeah, I just want to check the tail. And I'll probably want to check what is in the process queue as well. And then then I think I'm feeling confident enough. So I want to print out like, oh, this is the tail. And then I probably just want to print out also like, here's the indices, and we'll just print out like the first 3 or something like that. 1, because the first one would have been the root node, and we've just added new ones on. Okay, so let's try that out and see how well it does. Okay, I'm getting 2 9s. Right, so tail index 9 is correct. It's, it's 1 plus 8. Like me a 1 plus 8, but oh no, printed out 2 the same one. Alright, 8 on 10. Amazing. Maybe wait 8 on 10. Right, I'm gonna print out the whole lot. Mm. 6, 8. I think that's right. 3, 6, 8. Oh yeah, that is correct because we allocate the children in 8s, and because the siblings all sit next to each other in memory. So because the root node has no siblings, right, it just has 8 people next to it which don't exist. Yeah. All right, I'm feeling confident now. So what we're going to do is we're going to unleash the beast of a recursive um, shader. So what I want to do is kind of let it go. I'm going to let it off the rails. So put the safeguards back in. Not that. Oh, hopefully it helps us. So it doesn't keep. It's not a while loop basically. So yeah, if the stream goes down, I'll be right back. But you know, AMD drivers. Oh, we're still running. Look at that. Nowadays, there's a bunch of printing going on. I left it a print statement before I got rid of them all. So it ran, but I just don't know how far it got. So what we can do is we can just be like, because ultimately we're just trying to get to the leaf nodes. So if we can write out into this occupation buffer, we can then see the texture and be like, oh, there's actually stuff here. So the occupation texture, occupation map texture, there's basically, it's a 3D texture where each bit inside the 32-bit integer words represents a cluster that is completely filled with spheres, and we use that to sort of simplify. So what I need to do is say something like, oh yeah, yay, a leaf. And I need to put a value in here because my print code is kind of required on that. Something I need to probably adjust somewhere in the code base. Right, we've got some leaves. Probably overflowed a buff there in some way, I don't know. So this means, I think at least, that we should be doing some writing here. Should we look at that? Let's just say, like, do we get here? Right, and if we get here, we can open up RenderDoc and just actually see a visualization of what we've painted in the area. Okay, so I think we got to where we need to be. So we open up RenderDoc, and I need to get the latest RenderDoc, and I keep not doing this. But anyway, we're going to use an old version of RenderDoc. So if it has a bug, because I use an unstable build, don't blame the project. So I'm going to do a capture. No. So after the compute pass here, volume constructor. Yeah, yeah. Sorry, wrong one. Yeah, construct leaves. This is our boy. Do you want to look at the occupation map? View that. We need to make sure we're looking at MIP 0. Oh, there's the right MIP. Oh, I'm not seeing anything. Is it right at the right MIP? Yeah, the value shows up down here. Oh, there's slices. Let's get into the middle. So it's a 3D texture, isn't it? So we need to get in the middle somewhere. Okay, I'm not seeing any fill clusters here. I should be seeing something here, but we're not. which is a bit concerning. Like, um, highest LOD clusters count to the highest LOD cluster coordinate. Yeah, this should be banging stuff in there. Did I set this texture to anything? Is it a null texture? No, it'd be the first. Yeah, we did a read write on it. We've seen the barrier show up in render docs, so it's definitely syncing. My concern then is probably the coordinate, but we do have this debug code. Past Henry was on it. So I've already debugged this before, so the code should be fine, but I guess it's just some of the input variables have probably changed. I don't know. So we look at the cluster coordinate. This was 65 it was looking at. So what are we expecting? Layer 128. That's in the middle, isn't it? Oh, okay. Hey, what's this about? You got a D and a couple of U's. Are these not? We haven't got a node index, that's why. Let's just not print that out. Well, we could do the node index. I think it's called cluster node actually. Yeah, we got one. Man, I'm not sure if I should just obliterate the word node and just call them clusters. Because it just, but then node is like a tree. It's just one of them. Alright, let's print this out. Right, I don't see anything. Why? Let's go back to that 65 one then. Oh no. It was only so big when it's 33. Okay, so let's do 16. Oh no. No, it should be. No, but it's a cluster coordinate. The coordinate of a cluster within. Right, maybe I need to do something smaller. Let's do 32 then. I'm not sure, because like. So your cluster. Hmm. Yeah, so you have 256 cubed of spheres. Divide that by 4. That's 64. The 32 is the one in the middle. Alright, that'll work. No? So what I'm going to do is print this out. Oh wait, I've got this here. Here's one I made earlier. Right. Yeah, let's just see this data. Oh no, because the uh okay, cluster coordinate, but the space it's in, it's addressing the first sphere within the cluster. It's not like the cluster. Right, I see now. Um, yeah, so what are we trying to achieve then? What's the middle now? So the middle should be 128 or whatever. Let's just see if there's any that actually. Yeah, so they print out 1 because they're the highest LOD. Okay, so if you're printing out this cluster, um, you know, let's just print them all out and see what happens. Like, oh, it's a lot. Right, did we get like 64? Sorry, what's the chord again? What's the difference between cluster, chord, and chord? That's coordinate within the bit set that it's setting, right? Um, hmm. Let's try and get one that we shall remember. Let's do the one. Yeah, why is it 124, 188, and 60? Oh no, they are multiples of 4, aren't they? Yeah, they're multiples of 4. That's fine. What I get is why not get ones in the middle though? So let's do the. Wait. Why have we got 100? Oh no, 100 is a multiple of 4 in it because you've got 20 when it goes into 100. Should be right. So let's do this 100, 176, 48 one. Let's just see the sort of data we get here. So we're trying to see like where it writes into the image. I don't see anything here. Did I mess up my equal whatevers? Are these messed up? Because I did that Boolean change, you see. So can we write that in? Because I changed my Boolean code. So let's do 100. Oh, what $x equal 100. So if that works, then we've got a bit of a. Oh. But we saw. We saw it show up. Alright, so this one, 112, 152. And then let's put the if statement around here, so it only prints this, providing that that is true. And we'll see if we get them both printed or not. Why am I getting a different value that's printed out in the terminal now? So I'm getting this one that prints out correct. Did this cluster code get mutated? Oh yeah, this is good. Huh. What is going on? Yeah, because we're not seeing anything show up for 64 for some reason. Yes, the different values is fine. Or is it 128 we want to see? That's in the middle. That cluster should be there. But we're not seeing it show up. Okay, so we should be seeing... yes, it's just saying basically how it's written out into that. Sure. And the bit, why is the bit the same? Oh. Let me think about this. So this code should only be ran. Should this whole code only be ran on one thread? Like why? Like, cause you're on 1 bit per cluster. Basically. Yeah, we should probably be running this on one thread. I don't know why I'm trying to do multiple. Like, you can do multiple if you need to set multiple on a... Yeah, I guess that could be a performance optimization. Where you can just get it all to do it in one. But it should only be done on the first thread. But it's just in atomic ores anyway, I don't know why it's... But yeah, so that coordinate that's writing it into the texture seems too high. I think it's built for... So... Yeah, is that coordinate too much? I think that's out of bounds because it was only like 33, whatever it was. Cubed. So yeah, I think that's a problem. Yeah, so it's actually right out of bounds. That's one of the issues with it. So I'll sort of fix that. Right, I just need to take a quick break, and then I'll be right back, and we'll correct this up. And we also got to figure out why is it doing 100 and why is it not finding the one in the middle? So I guess we can see that when we get it writing out to the texture, maybe how the data actually looks in 3D. So yeah, I'll be right back. Right, so everyone, welcome back. So yeah, I just kind of realized that we took this code from another shader that had one thread per cluster. Um, but I don't know if it will be better. Because right now we've just got two waves, and only one of those threads is going to do all this code here. Um, but it might be fine, because this should only work on the leaf nodes, though, which is the issue. Yeah. So I need to, if not, if else then it just needs to push onto another buffer, like, hey, here's a leaf node. And then another pass comes over and just does them all in a more parallel way. But yeah, I think I just got to benchmark it. But yeah, it should be too hard to try it out. Anywho, not sure why this is buggering up. Chord is highest LOD cluster chord, divide by 2. Add XYZ. Hmm. Or is my texture big enough? That's maybe the other question to ask. Occupation map. Does the cluster dim? Is there 64? Yeah, along an axis within a volume, yeah, because it's 256 divided by 4. Does that many clusters divided by 2 plus 1? Oh yeah, because the repeated information, that's correct. Um, hmm. Right, so the problem is it's going, right. This needs to be divided by 4. That's the problem with it. This needs to be divided again, basically. Yeah, it's a problem when you copy and paste from other shaders and your input variables are slightly different. This actually just needs to be divided by needs divided by something like cluster dim. I think that's 4. Yeah. And that will fix the problemo. Yeah, so now working from 0 to 64. So that should now output correctly. Right, I'm not seeing anything in the printout. Okay, so I'm hoping to see like a 32. Because that's like in the middle of the... No, not 32. Wait. Yeah. That should be in the middle. Because there's 64 clusters across. Right, we're actually seeing stuff for the middle now. Because this is only printing for here. Oh, no. No, we're not. There's not stuff in the middle. I accidentally left this print. But anyway, we are seeing stuff that's going into the texture, which means we can actually visualize the data. So let's go and do that. So we run render doc. Get the texture. Here we go. So we're seeing something now. But we're not seeing everything correctly. For some reason, one, it's jumping around. Hmm. So as you go through the slices, you're going down the Z. Some is fishy. Fishy, fishy, fishy. Yeah, I got this working before, you see, but it was a different bug last time. I guess like the next thing to be like is like does like does the coordinate of the, so you shouldn't have any children on that. So we should look out for that cluster and see if we ever encounter it. Like we're not looking for coordinate highest LOD, what we're looking for is coordinate anyway. Cluster. So we're trying to find this one, which is 64. No, 128. And we're just trying to say like, none of that. Oh, just no, I don't see anything. So, what about moving it down to say, you know, let's just say coordinate highest. Yeah, let's try the highest LOD one. So you should see this a few times, right? We should see it on the first LOD and probably the ones after that. Alright, we just see it on the first LOD. For the child that comes through on LOD 1, so that's the second level of detail, should be intersecting there. So what I want to say is like, hey, if you are let's leave that one there actually. What am I doing? Yeah, what I want to say is if you're at LOD 1, tell me plus LOD. So if cluster LOD equal 1, what I want you to tell me is if for that node, I guess we could say coordinate highest LOD, did you intersect or not, right? So these are all the guys at LOD 1. So we're in the middle at 128, well 96 radius. So the ones kind of like in the middle, there's kind of a lot of data here. Let's look for 128. I'm not seeing that one pop up. Should I see if we can actually look for that? Let's see what happens there. No, does it go into here? It doesn't even get there. So what happened to... Wait, is there even a cluster there? There should be a cluster there. It's in the middle. The way this thing works. So maybe is my child, is this off? No, you see, it's taking. So I want to say, hey, if cluster LOD equals 0, then what I want to get is this. Splat 3 volume position so just write the word yes in there, just tell the difference. So we don't know. Yeah, it's a 444, isn't it? Where's the quad 4? So you got 8 children. These are a bit weird. I feel like maybe there's two. Like you got 8 children, right? It's an octree of children within the cluster. So within this cluster, it's split into an octree, right? So 2 by 2 by 2 in 3D. So these are sphere. These are the location of the child that we are creating in the next level of detail. So we've got the anyway, I haven't got any children. Then we're working out its yeah. So in the first LOD you've got 0 to 4. Or 0 to 3 inclusively, right? And then the next LOD has 2 clusters. So it should be 8. Right? So you should never see an 8. You should only see 0s and 4s. Basically. Or you should never see a 12. So along the y-axis, something very dodgy happens. And that should be my 4 by 4 by 4 there. So the y-axis is misbehaving. I don't know why that happened. In this code, I don't know why. Can I print out my child index? Yeah, so we're getting okay child indices. So then I guess I kind of messed up on so the z-axis is fine because it's 0 to 0 then 4 starts off as 4. That's right. What's the y? So the child index on the y you want to do that is just and 1. We did kind of do this earlier, wasn't it? And sorry, it's and 2 divided by 2. We kind of did this up at the top, wasn't it? Is that right? We kind of did it here, but then we flattened it out. I think. Yeah, so I kind of want to make sure this is, so it's and 2. Then I can just do, so it's and 8 divided by 8 and 20. Yeah, I just don't think this translated over from the old system, I think. Oh no, this is child index, not sphere index. Oh, this is different then. No, it should be right. So a 2 by 2 by 2 instead. So the 2 by 2 by 2 divide by 2 gets you 0. So mod 2 will get you 0, 1 based on the x. Divide by 2 will get you maybe you want like an and 2, I think. So I get you probably divide by 2, I reckon. I think that's what I'm missing. Oh no, it's not divided by and multiply by 2. Yeah, so now you got your quad 4 showing up. That's right, all the... Is it right though? No, that's the Z. Same as the Z, isn't it? It might be... Wait, so what is it then? First, you want 0 and 1, but not 2 and 3. But you want 4 and 5. 0 and 1 together. Um... Sorry, I didn't put the brackets around it like a melon. That's why. I think so. Oh, we're seeing more printing. Right, there you go. 0, 0, 4, 4, 0, 0, 4, 4. That's what we want. Okay, along that Y, that's good. Okay, so we're seeing more stuff pop up now. And we actually see... Alright. Let's... so I'm happy with that. So what's down here in this printing code? Yes, I only print if you're 32, which is the cluster index. 32 is the middle in the like it's at the highest LOD you've got 64 cubes of clusters and 32 is in the middle, and we're actually seeing this value print out, and it's printing out into the text, like within the, it's in the middle of the actual texture as well. So I think we've actually just nailed it now. So let's comment that out. Let's also get rid of the other printing code. Man, like big refactors really mess with code you've already written. Okay, so we launch this. Let me close that. Go to the shader and voila, here it is. You ready? Let's go through the slices. Here's our sphere. Boom. So we're actually seeing our sphere shop now. Each bit is a cluster. Right, and if you hover over here, you get a full set of bits. And that's a U32 max. So we're seeing the sphere placed down, kinda, in a low resolution. So that right there is this shader fully working. Well, okay, working with one edit and whatever. But should we compare the speed results? Oh, why was it printing? Because the thing is, right, okay, 32 ms. Maybe doing that as a separate pass was not so much of a bad idea after all. So what was it before we combined it? There was a Discord thing I did. Oh my days. So we, on the first version of this shader, it didn't include writing into the occupation map in the same pass. I think this is now a mistake after what we learned today. It's in this thread. I took a screenshot before we did the here it is. So we used to do many invocations of this one at each LOD, but I've now combined it into a single pass. And this is way slower. So we've actually already done the bench. Actually, we've actually got the benchmark results. So it is better if we make a generate occupation map as a separate shader, and that could probably... Yeah, and then we can actually compare the results of what this construct leaf nodes actually took. How the new one compares, basically, to the old one. So let's quickly go ahead and do that. I could go and grab the old code. What did we do? Thank you, sir. Jalatos, appreciate it. Alright, let's okay, so we're gonna make a new one called like gen. Rather than downsample, because that's the one that comes after. Because we need to... It's a gen occupation map. I forgot the inputs, but let's just go ahead and... So we just basically did like a... We want to do like a 32. One thread equals a... One thread equals a cluster, and you do 32 clusters in a wave. So let's move. So the basic idea is what happens in here is try and outload. Yes, what happens in what happens in this block of code here is that we just append to an array, hey, we've got a leaf node. And then the shader can just carry on and do the next bit of work. And then later on this gets a leaf node, and then it just like gets the data and oh shoot. Yeah, we need to also add it to another array as well, but we'll do that in a bit. Add it to the refine process queue. Interesting, we already have the array. Excellent. I don't have to do any extra work. So I just have to get the tail. That's amazing. I don't have to have an extra array. I can just look at that. So basically you want to get... Oh, it's going to be good. So dispatch index.x. So we want to get the tail. So I'm going to load the tail index out. So leaf nodes count. So you do a lovely little load. Yeah, one of them. Then lovely little load. So if it is greater than or equal to that, then we return because we've got an index that's out of bounds. Then you want to fetch a leaf node, or let's just say cluster index. BC refine process queue. Dispatch index. Pull that boy out. So now you got that. You can load the number of spheres if the number of spheres. You're not a fan of indented branchy code like that. Yeah. So you can shift this over. Very good. Alright. So yeah, what we're saying is just like, well, if the number of spheres don't reach this sort of like mostly full cluster, then we're just gonna return. But if it is mostly full, so I think it's just 56 out of 64 or more, then we're gonna go ahead and draw it into that. Draw it into that occupation map. Now, that all works. Everything called node still. Oh shoot. Yeah, so I think what I can do is actually just like grab the node, the cluster node, and this doesn't have to be atomics anymore because I think you'd have a barrier in between it. So that's all going to be set up A-OK. Yeah, so the barriers will do this, will do the cache flushing. Yes, right. So we just got to set up this. So I need the occupation map, obviously. I need the refine process queue and the cluster nodes array. So the occupation map, that's read-write. I need the refine process queue as read-only. And I need the read-only volume cluster nodes. And that should be pretty simple to set up. I'll be happy with that. Then we can see, because we've got 32 ms here, whereas in the past we saw it only took two ms to do it as a separate pass. So yeah, we're gonna hopefully get our gains back. So here's the downsample one. Let's just go ham and set this one up. So we need a refine, an occupation. Oh, the previous shader doesn't need an occupation map anymore. Yes, that doesn't need an occupation map anymore. This, I need that. I need the refine. That's read only. And I also need the cluster nodes buffers read only too. So I also need the global buffers as read only. And I also need to then launch the shader. And this is going to be the lovely, wonderful gen occupation map. And the code hasn't been generated yet, so I don't think it... If I do that, will it? No. Oh, it's SV, isn't it? Whoops. SV for system values. Not BC for bundle constants, right? Get these shaders compiling quickly. So it's saying that it needs this highest... Oh, whoops, grabbed the wrong one. Cluster LOD to highest LOD. Where does one make that? So let's get the cluster LOD as well. Right, does that compile now? Right, how many of these are we launching? Oh, it's got to be dispatch indirect. Sure is. Because we only know based on... Alright, but we can fill that in, right? No? No, also complete. Right, occupation map. That's right. Oh, no. Cluster. There we go. So yeah, we actually need to make this indirect, which means we probably want to put it. Yeah, I kind of want to like this one, I think. So the it's going to be in the globals buffer, which is accessible from GPU. We just have a bunch of little variables in there. So it's accessible from any shader, which is globally there. So I guess we just say it's the volume cluster gen occupation map. Indirect args. Yeah, so what you want... not easy. Because you need it to be divided by 32 at the end. That's part of the issue here. Part of the issue is so you need to have one shader clear. So volume, select constructor reset. This shader I'm just going to want to already set that to 0 and the rest to 1. And then like whenever you like, so whenever you sort of like add, there's like, hey, I found a leaf node. You're gonna want to say, like, so it's like, hey, I found a leaf node. Bump this by 1. But the problem is it now needs to be divided by 32, which is this, because that's how many groups you're launching. So you could do another shader after this and then do it there, but, sorry, or you can just say, you just got to get it right though. So when you return, which is in here, there's only one place you really return. There's a safeguard though. So that should probably be set to 0 at that point. Yeah, you're right. But here, you kind of want to be like, yeah, I guess you're going to say, if I am sv dispatch index.x. This is really bad. If these are all 0, equal to you in it. Yeah, so on the first thread I have everything that's been launched. Then I want to set, oh my days. Set this one to divide equal 32. Should work. So does it all compile? Yes. What I would like to do is rather than, fire it off right away and be like, that's amazing. I kind of want to do some printing and quickly check if they are all okay. So we're just going to do something like this, where we put the two values, which should be the same. Yeah. Wait a minute, is that going to be a divide around up? Yep. Oh. So what am I looking for again? I think I'm looking for a shall we? Yeah, let's print out the two values. Maybe we could. What's the other value I'm looking for again? This one, this tail index. Right, I guess we'll multiply it by 32. Alright, see how this goes. See if the stream crashes, which it shouldn't do. I'll be right back because I have to restart my computer, but it should be alright. Hey, Chris and Mania, how's it going? It's been a while. Why is it still taking so bloody long? I've saved 2 milliseconds. Something's really bad with this shader. But anyway, looking at the results, they're kind of different every frame. Oh shoot. Oh no, that's right. So it starts off as 0. We didn't atomic it, did we? That's why atomic. How's it going? How you did? Did you have a good trip? Yeah, I'm doing good, man. Doing good. Yeah, wrestling with shader code. But yeah, the trip was awesome. Too busy doing stuff every day. I only really had 2 rest days for the whole month. Did a lot of stuff. A lot of sightseeing, seeing family and that as well. Yeah, a lot of fun. Yeah, I'm glad to be back there. As well. Very very warm out there. Very warm. All right, we're seeing. Oh, it's not good. We should not be seeing. It shouldn't be flip-flopping. Oh yeah, this has got to be atomic. Atomic store, that's why. Atomic store, atomic load. Oh, it is. Atomic all of the things. Eh. Yeah, I don't know how well this shader's gonna be, because it's looking like the performance is bad, but maybe that's just because we've... Well, actually, I don't know. Something's overrunning, I reckon. There's just too many iterations going on, and it's probably running until max iterations. That's the reason why it's so slow. That's alright, it'd be good to debug that. Level of detail. Oh yeah. Let's get the V in there. What do you mean load, yeah. Right. We're still seeing that same sort of number, but it does show 0 sometimes, and then my head is like, why? But yeah, so we should be seeing, oh, this needs to be an atomic load. Cry out loud. Um, oh, right. I times it by 32 in it. Right, so equal to the same thing, that's what we want. But then it's sometimes equal to 0? Like, in what crazy world? Right, because sometimes when it terminates, it's not... No, that can't be right. It's the first thread. What could be going on that sometimes it's equal to 0? Because they get increments at the same time. But then I guess... Yeah, they get increments at the same time. So by the time there's all of the buggers waiting to then terminate... Yeah, that's right, distance from the camera. Yeah. Yeah, so essentially like a MIP level is like a level of detail. So that's right. But yeah, we're not doing polygons. We're doing spheres. So, yeah. That's different. So why is my dispatch args now weird? Like, why is it sometimes 0. So that means this one must be, this compute unit must be terminating. No. So what's going on? Why is it 0? You do the store. In the reset, it syncs with a barrier, CPU barrier. So the barrier you tell it from the CPU, right? The pipeline barrier in the command buffer. So outside the shaders. We're only getting one of these threads come in here. And if it's done the other one, it should have. Like, so if the tail index has a value, that's the bit I'm super confused about. Let's do another load on it at the same time. It should be 32 times less than. And it's just always 0. And what crazy land am I living in? Let's try the wires. It's not just a performance optimization. It's actually as well to make things look correct. Because your pixels, you're basically making you like you say with an example of triangles. If you've got a pixel and you've got really teeny triangles, super teeny triangles that form your mesh, these will not color the pixel. They only color the pixel if they go over the sample side, right? That's not a triangle. Then the sample point of a pixel, right? So by doing a lower LOD, you actually essentially take all of those triangles and you average it onto. Yeah, then you've got your texture as well, which is a lower res as well. Anyway, so by the time you sample, and get the sample it and get the texel right, it will actually be a downsampled version of it versus randomly getting any triangle on your very low resolution model. Right? So it's does it for two big reasons. But same thing for bitmaps as well. That you have a downsampled version of textures for that same reason. And if you don't understand exactly, you can probably look more at Learn OpenGL bitmaps. Get a different take on it. Does it show MIPS? Yep. Bitmaps. Do they show a good idea about why you need MIPS? I don't think they do. They just say, hey, generate MIPS. They're a thing, maybe not. Yeah, maybe they're in a different thing. Anyway. Is it changing random passes? I don't think so. It should get reset every frame to a valley. And then we'll be incrementing it as well. Maybe some. Yeah, you'd just have too many things to color in, and the algorithms won't scale. So the only choice is to increase the resolution higher, or have a lower resolution version of your stuff. And this is bloody weird. Alright, we're gonna write out. Oh, damn. It's a number. Oh, I'm printing out Y. Hang on, other X's. Alright. Try again. Why were the Y's? Oh no, I tried it the Y, it was 1. Yeah, no. We've already done this. X will be 0. Yeah. So the Y was 1, I did it for a test. Print out a number. See, the number is going up. And it's going up sensibly. So is this it? No. I cannot think of a reason why. I cannot think of a reason why when this terminates, the tail is going to be set something different than... Right, unless it's my divide round up thing that's messing up. No, this is always equal to 0. What? Atomic load. Atomic load. That guy. I could just take the tail index. Right. And then do that instead. And then store, because it's just the same number. But I'm still, like, is there an optimization that's going on? But it can't be, because it's happening every 4 frames it happens fine. It's just a little bit confusing. Right, it's still blinking like a burger. If I print out V, let's print out that in there. Right, I'm just going to believe that it always gets set and there's a bug somewhere going on. It feels like it's getting set fine. Alright. I think it's fine, basically. So we're going to now bring this gen occupation map in. And so we'll, if stream crashes, I'll be right back. Should be alright though. Here we go. Alright, we're running. So it's still. So gen occupation map is actually dirt quick. It's quicker than it was before. So this leads me to believe something isn't right. So we're trying to see a very low resolution version of this sphere rendered into this occupation map. So it's basically a bit set where each bit represents a cluster. Okay, 0 is being launched here. Right out loud. So it still runs once, even though it's got 0 in there, I think. I want to see where it runs okay. So I might be better off by just literally just making another shader, and just say, set up the args, and just running that. Like, it sucks real hard. Um, and it just does the division, then ends. And you have one of them that launch. So you do a load from the tail and store it. You don't need to do the atomics now because you've already got the sync code from the pipeline barriers. So it should just be as simple as that. So now you can guarantee they'll finish and that everything's synced. I don't know what's going on there. It's just really weird. Yeah, we'll just launch that. So it's literally just a copy paste of this. So no constants. Then we synchronize on there's read write on the global buffer, which is just globally accessible. It's just a hard coded integer, and we just call the setup shader. And this is a regular dispatch, thinking about it. And we're launching just one group and using one thread within that group. Oh, just that works, right? So let's now sync and run. So if it crashes, I'll be right back. Here we go. Alright, we're still running. So the setup shader runs, and this runs for a little bit longer, maybe? I don't know. Let's rerun it in RenderDoc and see if we can get the image back up again. Alright. So, okay, so it is being dispatched more than the correct amount of times. This is great. Looking back at the benchmark information, what we're seeing is that the generate occupation map was taking 0.2 ms. But in this one, it's taking 0.02 ms. Something is fishy. If it works, then I can't argue with it. It works. There we go. So we're seeing a bit so where each bit is a fully occupied cluster. So we're going through the slices and we're seeing it. The single sort of edit operation, we're putting a sphere down. And it's each of these each of these clusters is a 4 by 4 by 4 set of spheres, right? So each bit is each bit within this bit set is a cluster. That's pretty cool. But so now let's try and see if we can. So what we've realized is, I don't know how it's faster. Moving out to a separate shader. Sorry. I don't know how this is faster this time around, because we literally had it the same. But what else could be the difference between that benchmark? What was it? The clusters. Yeah, maybe we've got a smaller list. We might be going over a smaller list of clusters. Oh no. Our clusters used to be 2 by 2 by 2. Now they're 4 by 4 by 4, so we have less clusters to process. It's probably that reason. All right. So yeah, there's essentially like there's 8 times less clusters, so it should be maybe 8 times faster. It is, isn't it, roundabout? About 10 times faster. Yeah, okay. Good to know. Why does this take 32? About 32 ms? Whereas this previous implementation. Now the reason why I went away from this implementation is because I needed to dispatch. I needed to dispatch one for every level of detail, and check every sphere for every level of detail this way. The new algorithm only launches over the clusters which have information. Sorry, which have edit operations which go in that area, and it starts from the top and it works its way all the way down. This should be quicker because it's doing less clusters for that reason, and because it's doing 4 by 4 by 4s instead. Actually, no, maybe not because of that. Yeah, maybe actually, yeah. And yeah, that's basically the reasons. So it should just be quicker. So we add all these up, it's probably about nearly 5 milliseconds, maybe, or maybe 4 point whatever. Yeah, about. Yeah, I know. 4.5 milliseconds or something like that. So we should be getting that, but we're not. So if we go up to the shader, what I want to see if there's any sort of like anything crazy going on. Does this thing trigger basically? This where it spins for too long. It spins for too long. So it seems like that's I don't know. So it means that it only spins for too long when. How does it get here? Yeah, when this runs for too long. Or maybe this runs for too long. So what I want to know is if iterations 2 is equal to or plus 1 is equal to max volume nodes, whatever, then we'll do, hey, you've spun for too long. And then we'll do the same thing for this one here as well. 1, then 2. So I want to see which one of those buggers is actually spinning for too long. None of them. Bum bum bum. Um, so what could also be happening is tons of threads just terminate early, and then all you're left with is one. Sorry, tons of compute units or whatever, or thread groups terminate early, and you're just left with one, and that one just keeps going around. That could be the other thing that's going on. So all of those threads which should be processing just end to end literally right away when the thing sets up. Let's double check I got this right. So if that was that, that means you reach the final one. Yeah, sure, print out. Try again one more time. No. Don't see anything show up in the terminal. So, what could be the other reason why we get this triggering? Because this cluster index gets stored here and it only breaks from here. So if you don't finish this loop, so what would be interesting to see is maybe you run for the first frame and just sort of see, or the first LOD, and just see where things end up. So we do one iteration there. So I should probably disable some of the future stuff. So we do one iteration here for the, so the sort of this dispatch group only gets one chance to grab from the queue, do one job, then leave. So this will then mean we can just see like, oh, it tried to it found me a job. Oh, me a cluster. And then this one is like, so in theory it's like, if we get these first, they're spinning too long, then it must mean that they terminated before. Is that right? Yeah, they terminated. Hmm. Hmm. It's this ending now one as well. Right, let's print it out and just see what we get. Why are they all like, I found me a cluster? Is it going for multiple levels of detail? Um, Right, let's give that a go. So we have to see the LOD that it's working on. Okay, so it's actually doing more than one node. So it seems like they are picking up the jobs. They're like, oh, I found me a cluster. And they're going and doing their thing. That's alright. And I'm just quickly double check it's... I'm only seeing 3s in there, but maybe that's... I don't know why I'm only seeing 3s in there. Is... Wait. Yeah. Right, anyway, so it's doing... Yeah, I wonder... how it got here. Spinning for too long. When none of these guys said they span too... let's go to that and see if they say ending now. How are these things ending? There's ending now. And then there's spinning for too long. And they should both be printing out something. So you've got... It says actually running. Sorry, this is only running for one time, isn't it? I did kind of forget that. Sorry, it's only running for one time. Maybe we should... See, I wonder if this... So launching... Yeah, what we put into there is what we put here as input, as how many dispatch groups we're launching. And load... Alright, so let's put the total number back and see if it says ending now. Okay, saying spinning took too long. So it reaches here. What happens if I remove this? Does it show, do any of them end now sensibly? Some of them do. See, maybe this plays into the fact of the other issue was getting. The fact that... But why could this be... So do a store into it here. I wonder if that's making things actually wait. Do they call it a control barrier in SpearV? Yeah, we got these in there. Yeah, we've got some control barriers in there, so they should be waiting until it's all synchronized. Wait. No, yeah, until they both waves get there. I want to synchronize more than maybe let's change that. Maybe I need different sort of control barriers. Let's change some of this stuff. Control barrier all. Now we've used atomics. I'm a bit confused. So a bunch of ending nows. Let's refine LOD. Let's get back to the one. Where is it? Ending now. Ending now. Oh, it's some old code. No. Yes, let's put this one back. Do we see any of these boys show up? Yes, we see spinning for too long still. Alright, let's have one quick glance. So, you store U32 up here in, you know, LDS memory. This loop is a chance to break out. All of the threads, all of the wave 32s that run in lockstep should wait here until the other one until they've all got here, right? So you need break out. So yeah, only the first thread goes into this if statement in the first wave. And it goes around and does all this, gets the cluster. The only time you get a proper cluster is when you get this here. I should probably say if cluster we should then probably print out something like what? Because that shouldn't be happening. Okay, no what's storing in there. So what about if we load the cluster index out of here now? Does that? Okay, no what's still. So we're going inside here, coming out here, and we always know, no matter what, we've set a value apparently. So it's as if it's getting past here on one of the waves. But then we're seeing the whole sort of like thing being. We're seeing the whole sphere set. So how can it partially get there and eject like some of the waves? It seems like we're always getting a cluster to work on. We're always getting a cluster to actually do some work. Right. I think that would be a good place to put a pin on it. Because I'm a bit confused right now. But so in the next stream, which will be on Tuesday at 6:30, p.m. GMT. I think that's right. There is a schedule on Twitch if you want to see the exact details. But yeah, we'll investigate why this shader's taking too long and compare it to the benchmark that we got. But we've got an occupation map up, which is super great. And we use that in the next shader, which will refine and simplify the tree, which will build the lower LODs and put all the correct spheres in there, which we've had working in the past. We just got this new queue system, this new queuing sort of system. And then after that, we'd get the make persistent shader working. So hopefully we can get all that done in a single stream. And we'll see. But yeah, at least we got something working today. It's good. Yeah, shaders be shaders. Yeah, they're bloody hard to debug, put it that way. Like without this printing stuff, it'll be even harder. Like, how could you debug a compute shader without printing, you know? Like, you really need to put up your own sort of like, you know, work in to actually get some interesting debugging. Thank you, Jam on Toast. Appreciate it, sir. I'm gonna go and eat some food. Got some food from church. I'm gonna eat some of that. Probably work out a bit and then go to bed. Watch some YouTube, you know. Why don't they just show me science and you know what? I might just bail. Right, I'll see you all in the future stream. Thank you so much for coming, and have a good start to your work week, guys. So otherwise, onto the board. Yeah, you guys are all from scratch. Yes. But yeah, have a great start to your work week. I'll see you all in a future one. Right. Catch you later all.